everybody, and welcome to the Multicloud track, which is track 3. My name is Dominique Top. I'm a solutions engineer at HashiCorp and residing in London, UK. If you've been to any of the local meetups here, you may have seen me before. You may have known me as DevOps Dom, although I've recently rebranded to DevOps Dummy. I'm super excited to be here today. We'll be chatting with you throughout the whole day. With me today is my co-host Charlotte, and who is going to be introducing her to you right now. Over to you, Charlotte.
Thank you, Domi. Hey, everybody. I'm Charlotte, and I'm your co-host today and an engineering manager at Container Solutions based in Amsterdam. We have a lot of exciting talks today on track 3 with a lot of multi-cloud, Kubernetes, and SRE topics. So it's a good mix. So we believe you chose the absolutely right track for today. And Domi and me, to be honest, we are the funniest ones. So this is a good one. And there will be a lot of other activities. You've heard about this before. So quizzes, chair yoga, DJ, and a few panels. We do have a code of conduct. Can you tell us a little bit more about that one today, John?
Yeah, of course. So just so you are aware, this community is an open and inclusive one. Jamie already said it on the main track, but I want to repeat it again. As I said, operate on the code of conduct. You can find it in the sidebar on the right. But basically, the TLDR is basically don't be an asshole. So once more, back to Charlotte with a small word about our sponsors before we can introduce to you our next speaker.
Yeah, and I'm not going to go down the sponsor list again. You've heard that already, but we do have the sponsor booth. So if you click on the left side, the 2 shaking hands, you can see the booths, and that's where the swag is. That's where the gifts are. So check those out, and feel free to join the conversation on Twitter using the hashtag #WhatTheFuckIsSRE.
Oh yeah, so now it's time to finally welcome to the virtual stage. You may have seen her pop in and out already. It's Praise Adanlawo. Welcome very much. How are you doing? Welcome, etc. I'm so excited. I'm not lost in my words.
Hi, good morning, everybody. I'm so excited for this session today, and I hope you're going to learn a lot from this session. Yeah.
All right. Well, when you're ready, when the slides are up, then I think you can take it away. Have fun.
Yeah. Thank you, Dominic. So hi, everybody. As Dominic said, my name is Praise. I'm Praise Adanlawo, and I'm a site reliability engineer at Deimos Cloud. So today I'll be taking you through Kubernetes and GitOps better together. Now, a lot of people use Kubernetes. A lot of people use GitOps. They use them separately, but these two can function and blow you away, literally. So today I'm just going to give you like some sort of brief introduction into how you can use both and how you can maximize the benefits that they both bring together. So without further ado, let's just go straight into the slides. Yes, so there are 3 main concepts here that are very important that I think everybody should know about, which is Kubernetes, GitOps, and multi-cloud. Now I'm going to explain these 3 concepts in brief details before I go into the demo to show you all the goodness that GitOps is. So first, we start with Kubernetes. Now, a lot of you might have heard of Kubernetes. A lot of you might have used Kubernetes, and so many people might not have used Kubernetes before. So if you're in any of these categories, just listen on. So yeah, the key word when you want to talk about Kubernetes is orchestration. Now, I know you're going to see, if you search for what is Kubernetes online, you're going to get a lot of definitions, something about if there's an orchestra playing and, one conductor is managing the instrument and another and all of that. But I'm here to take it simpler and give you like a bottom level definition of what Kubernetes is. So let me just read through my slides first of all. So Kubernetes is an open source toolkit for building a fault-tolerant, scalable platform designed to automate and centrally manage containerized applications. Now, 2 keywords here that I need you to note is infrastructure and containerization. Now, these 2 things are, so for infrastructure, we have the immutable infrastructure, and then we have the containerization. Now, for immutable infrastructure, this is such that if you have a server, you want any deployment you make to the server to not be able to be changed. Let me explain that. So if you have a server now, you have an infrastructure. You see, an infrastructure is immutable when if you need to make modifications to it, you have to take it down and bring it back up. You can't make changes to the server while it's still there. That's what an immutable infrastructure is. And then for containerization, for some of you that are software engineers or that have some experience with building applications and the like, you would have heard of containerization a couple of times. Now, containerization is such that you can package your application. So let's say you have any application written in any language, you can package it such that any system you want to run this application on, it stays the same. The code base, the dependencies, the environment variables, everything you need is packaged into something that is called a container. And then if you need to run it on a Linux server, it's the same. If you need to run it on a Windows server, it's still the same. So that's what containerization is. Reading on, the platform itself, talking about Kubernetes, can be deployed within almost any infrastructure, in the local network, server cluster, data center, any kind of cloud, be it public, private, hybrid. And that is what we're going to be demonstrating today. We're going to be showing how Kubernetes can be deployed on multi-cloud. And my cloud of choice is two public clouds. I chose AWS and Google Cloud, right? So it is noteworthy that Kubernetes supports the automatic placement and replication of containers over a large number of hosts. Now, what does this mean? If you deploy your application with Kubernetes and it's supposed to help you manage these applications, you need to be able to, you don't have to worry about, oh, is my application down? Are the pods up? Are the pods down? And all of that. Kubernetes manages all of that for you. And then it abstracts some of these details into the background. So you don't even see all these things running. Your own concern, your only concern is my application is up and it's running. Now that's fantastic. Now, Kubernetes is not something that I can explain to you in 1 minute or in 2 minutes. So this is just like a brief run through to give you an idea if you don't already have an idea of what Kubernetes is. Now, I also put this link here for a Kubernetes comic made by Google Cloud. It's interesting. I think you should take a look at it. It helps you understand what Kubernetes is on a playful level, right? So that's just that. I'm going to be moving into Gitops now. Please, if you have any questions, you can paste them in the chat, or towards the end of the talk, I'll paste the link to Slido where you can send your questions. So now, the second key feature we want to talk about today, GitOps. Now for this, so many of you might not have heard what GitOps is, and so many people might have. So I'm going to try as much as I can to break this up into the simplest way possible. So first, GitOps is a way of implementing continuous deployment for cloud-native applications. It focuses on a developer-centric experience when operating infrastructure by using tools developers are already familiar with, including Git and continuous deployment tools. That is, having a Git repository that always contains declarative descriptions of the infrastructure currently desired in the production environment, and an automated process to make the production environment match the described state in the repository. Now, if you feel like all of this I've read is gibberish, or it feels like it's too much for you to take in, just hold on. Okay, so this is what all of this talk is centered about, and there is going to be a demo for you to see how this works. But in essence, what this just means is you have a way of putting continuous deployment. Now, I didn't want to go into the details of what continuous deployment is, because that's another conversation on its own. But all this does is it helps you do your continuous deployment in the easiest way possible, right? It focuses on a developer-centric experience, meaning that you as a developer or you as an engineer, you're using the same tools you're familiar with. You're using your Git and your continuous deployment tools. So all you need here is a GitHub repository that holds your described infrastructure, and then you need to connect it to your cloud native application, which in this case could be Kubernetes that you've deployed on the different cloud providers, right? We're going to do a demo to show you this, so you can just hold on with your concerns. So if you want to deploy a new application or update an existing application, all you need to do is update the repository. So it's a case of you controlling what is happening within your Kubernetes cluster as regards infrastructure, you can control it from your Git repository. So if you need to change something in your Kubernetes application, all you need to do is go into this Git repository that you've specified, make the changes there, and it reflects automatically on your Kubernetes infrastructure. That is what GitOps does for you. So it abstracts a way of managing your Kubernetes infrastructure by using Git. That is all GitOps does for you. So I saw somewhere that it's like having cruise control for managing your applications in production. That's just it. So it is version controlled, so you can easily see changes that have been made before now and know what and why those changes were made with comments and all of that. So let me move fast to what multi-cloud is, which is the third in this series of important features. Excuse me. So multi-cloud in simple terms means that instead of using only one single infrastructure as a service cloud provider that best meets the needs of the business, you can use a multi-cloud strategy. That is, you can adopt AWS and GCP. You can choose to use GCP and Azure. You can choose to use AWS and Azure. So that way, now these examples I gave are for public clouds. You can still use private clouds and hybrid clouds. By hybrid, I mean you using a public cloud on one hand and a private cloud on the other hand. Then you use it together, bring it together to build your infrastructure. So that's just all multi-cloud is about. Having two or more cloud providers and share the workload between them, basically. So I said, in other words, it means choosing services that provide the most considerable flexibility, reliability, most features, or are offered at a much better, probably cheaper price point. So like I said, this can be a combination of software as a service, platform as a service, or infrastructure as a service models. I also included a link here that could help explain what multi-cloud is better, because this is just a short talk and you might not be able to grasp everything you need to know about multi-cloud right here. So moving forward, this is the step before the demo. So here we're saying GitOps with ArgoCD on Kubernetes. Remember that when I explained GitOps, I said it is a continuous delivery tool that helps you manage your Kubernetes infrastructure by using Git repositories. Now, you can use ArgoCD to do that. ArgoCD is a GitOps continuous delivery tool built specifically for Kubernetes. So you have ArgoCD as the tool to use. So if you want to use GitOps, to be able to link your repository to your Kubernetes clusters, one way to do that is simply by using ArgoCD. ArgoCD was built specifically for that, and that will be our focus for today's discussion. So ArgoCD is implemented as a Kubernetes controller, which continuously monitors running applications and compares the current live state against the desired target state. So this is what it means. It means that there is a mirror between what you have in your Kubernetes cluster and what you have in your Git repository. Now, at all times, it has to be the same thing. That means what you're seeing in your Git repository has to be the same thing with what is on your Kubernetes cluster. Now, if for any reason you want to make updates or you want to make changes to what's in your Kubernetes cluster, you can easily, like I said, you can easily change it on your Git repository. But then, have you asked yourself, how does my Kubernetes cluster know that some changes have been made to this Git repository? The simple answer is ArgoCD. That's what ArgoCD does for you. So it makes sure that at every point in time, what is on your Git repository and what is on your Kubernetes cluster stays the same. That's why we use ArgoCD. So it is implemented as a Kubernetes controller. Because it is a Kubernetes, so ArgoCD is installed on the cluster itself as a controller. So once you have ArgoCD installed as a controller on the cluster, it is easy for it to be able to know that, oh, there are some changes from your repository and it needs to make those changes in the cluster. So like I said, a deployed application whose live state deviates from the target state is considered out of sync. And ArgoCD will keep nudging you to tell you, your cluster is out of sync. The cluster is out of sync. The cluster is out of sync. and it's going to keep telling you to try to sync your cluster. By syncing, it means make sure what you have on your Git repository is the same thing as what you have on your Kubernetes cluster. Now, ArgoCD has the ability to automatically sync an application when it detects that there are differences between the desired manifest in Git and the live state in this cluster. This is what I've just explained. So that's why ArgoCD is built specifically for this purpose. It can, once it checks, so it runs a periodic check to see that, okay, what we have in your Git is still the same thing. So it keeps running the periodic checks. And when it sees that there is some sort of deviation, no matter how little, it tries to automatically sync them. And if for any reason it cannot sync them, probably because of bad manifest or whatever, it gives you that nudge and states that your application is out of sync. And then you will not see the changes on your Kubernetes cluster. So it's like a foolproof mechanism in quote. So before we go into the demo, I just wanted to show you these two diagrams that I have. So this is like a step-by-step explanation of what I've just been saying since morning. So you as the user, you have your code, right? You push your code to your Git repository here. And then you use a CI pipeline to push the image to any container registry of your choice that you're using. Could be Docker, could be ECR and the likes. Now you have your CI pipeline to do this. If you make changes, you push the same repository again, then your CD pipeline syncs it with ArgoCD, and then ArgoCD takes those changes and deploys it to your Kubernetes clusters. Now, this is a more clearer description. I got this architecture from Level Up Coding. Now, as a developer, you commit your changes first step to your code repository. Now, your source code, your Docker file, that's your container, and your pipeline, you push it to your code repository. And this is using GitLab as a case study, right? As a repository case study now. Then it pushes it to your pipeline. Your pipeline builds your image, that's your container, builds your image and pushes it to your Docker registry. Now, the third part is that if you make any changes whatsoever to your code, it comes, can you see that these two repos are named? One is named the code repository, which is point 1. And on point 3, we have manifest repository. Excuse me. Because your code repository is where your application is stored. By application, I mean your source code. And then the manifest. Manifest is where you have the Gitops, right? So ArgoCD, you can see the arrow goes the other way. ArgoCD is constantly trying to sync what you have here. And then when it syncs it, it deploys the changes to Kubernetes. This is what we're going to be seeing. Now, I'm not going to be showing you the top level because that is not the focus of the conversation today. I'm just going to be showing you how the changes from your Git repository will be pulled by ArgoCD into Kubernetes. Now, this is demo. Please, if you have any questions, send it to me on Slido with this code 236561. 236561. So straight up. So yeah, I already wrote a Terraform script that deploys AWS and GCP. So I have it here, and I already linked the GitHub to the slides. So if you want to take a look, I have the code here already. So this is a Terraform code that basically just deploys AWS and GCP. Now I already have them deployed here. This is my GCP cluster here, and this is my EKS. So this is GKE. This is EKS. I just wanted to show you. So to save us time, I already ran the Terraform scripts and kept it here. But one thing I would want to show you is this. So this doesn't only, let me show you from here. So this doesn't only deploy Kubernetes. Like I said, it deploys ArgoCD as well. I'm using an ArgoCD module that was built by a few engineers in my company where I currently work. That's Multicloud. I also contributed to the repository, the Terraform repository. So yes, we built this and we pushed it. So you're free to use it, right? So I made reference to it here. It deploys ArgoCD for you. Like I said, ArgoCD has to be deployed on the Kubernetes cluster. Then you have to point it to the repository. Now let me show you. So here, I have ArgoCD here to be deployed on my cluster. That's why you can see it here. It depends on the Kubernetes cluster. And then I also specified within my ArgoCD definition, I specify that I want you to pick this repository. Now, this repository I have here is what I have here, which is my Gitops repository. Like I said, remember I said that your code repository is always going to be different from your manifest repository. So I have my Gitops here, which is EPS, and it has this folder. This is also public, so if you want to take a look at it, you're free. So all I'm doing here is I'm only deploying Cert Manager and Nginx controller. Now, I have not applied these changes to the cluster yet, so I just wanted to show you that before we go. So I'm just going to show you here. I'm going to try to log into, okay, you know what? Let me just log into just one. So I'm switching context. Let's try to get namespace. You would see that we only have ArgoCD deployed for now. So yes, we only have ArgoCD deployed for now. ArgoCD is running. Let's just, sorry. So this will show you everything running in ArgoCD, and you can see that ArgoCD is running fine. So I'm just going to, sorry. Can you see this? Sorry, let me do this. Please let me know if this is better. Okay, thank you. So yes, so this is just to show that everything is running fine on ArgoCD. So now we have your ArgoCD cluster. I'm using the GK cluster now for the test. Now I'm just going to, let me try to port forward from here. Sorry. Okay, so I'm just going to port forward. Yes, ArgoCD. So I want ArgoCD to run because this was a demo. So I don't have any ingress behind ArgoCD. By that, I mean, you cannot go to argocd.praise.com. I don't have any of that set up. So I'm just going to port forward from the server so that we can access ArgoCD on port 8080. So I'm just going to do that, 8080. So it does this as a check because it's HTTP. Let me try to get the credentials. Please let me know if you have any questions. Send the questions to Slido. The code is 236-561 if you have any questions. So let's sign into ArgoCD. My time is almost up. Yeah. So yeah, you can see no applications yet, right? Even though I have rightly connected my my ArgoCD to GitHub, and I did that on purpose because I wanted to show you guys how it is. So I'm just going to try to sync it. If you try to sync it and it doesn't sync, we're going to create a false application. So try to force it to pull the GitHub. Now don't forget that from here, I'm deploying Cert Manager and Nginx controller into this cluster. As you can see here, when I did the namespace, these are all the namespace we have. So Cert Manager and Nginx is not here yet. So let me do this. Let me try to create a false application, just call it something. Project will be default. So I'm just going to pick this. This is not always necessary. I just want to use this to force pull the what's it called? I want to use this to force pull the application. So let me see if I can create this now. Remember, I named this HHHHH. Now, can you see? I named this HHHHH. I can delete this now. I can delete this because it's not necessary. Right. So I can delete my HHHH now. Can you see that it has deployed Cert Manager and this? If you see this, I don't know if you can see this. increase the size a bit. You can see this, it's rolling unknown. Now, this ArgoCD application is just what? Sorry, I don't know why it's showing this error. This ArgoCD application is what manages both guys here. So we have Site Manager. Sorry, 1 second. Error creating necessary. Sorry, let me try to. Maybe the demo gods are not with me today. Because I tried this before and it was working fine. So I just want to show you real quick. My time is almost up. Yeah, my time is almost up. I'm fully aware. So I don't know why this is showing this, but we have this two. So you can see here that ArgoCD here is trying to. If I was able to fix the error now, you'll be able to see these two applications now. So you can see here that it is still trying to sync because it is not there yet. So it's supposed to create the namespace for me. That's the Site Manager namespace and the Nginx namespace. So even if you had more applications, you'll be able to see them here. Don't forget, this is where I have Site Manager and Nginx deployed. So you can always take a look here and try to deploy the same. So I deployed Nginx. I use customization to deploy Nginx because I don't want to do any other thing. I just want to deploy this Nginx URL. So just take some time, look through this. And I'm very responsive on Twitter. So if you have any questions after the conference, you can always send me a message on Twitter. My time is almost up now, and I need you guys to ask me some questions. So yes, okay, so these are the references here as well, to the Gitops repo and the ArgoCD repo. Thank you so much, everybody. Thank you for your time, and that'll be all from me. So let me know if you have any questions. Over to you, Dominic. Or
Excellent.
Thank you.
Yeah, thank you so much, Praise. That was awesome. Like there are so much. Like I did send the your Slido link to the chat in Brella. I'm not sure if they actually got questions on your one, but we did actually have some for you.
Okay.
So yeah, I think we have I think about 5 minutes before we encourage people to go to the stretching sessions and the networking sessions and everything. But okay, so here goes. One of the first questions that came up was from Ivan. I've seen a lot of approaches how to deploy apps in Kubernetes using GitOps. What about how to deploy clusters themselves using GitOps?
Okay, so it is not advised to deploy clusters using GitOps. I'm not sure I've ever seen that work before. So GitOps would work best for manifests. That means every other thing that you need within your Kubernetes cluster, not the cluster itself. If you want to manage your Kubernetes application, it is best to deploy it with Terraform. So that way you can deploy and then you can roll back at the snap of a finger. It's that easy. So as you can see, I also use Terraform to deploy my cluster, meaning after this conference, I can go ahead and pull it down and that will be all. So it's best to use Terraform. Use GitOps only when you want to deploy manifests within the Kubernetes cluster.
Yeah. As a HashiCorp person, I have to say, like, I'm very happy that you use Terraform to do this. So I think, yeah, great advice. I hope that was the answer to the question for Ivan. I think Charlotte has a few other questions for you.
Yes, the next one is from Anonymous. What tools do you recommend for monitoring once you've deployed Kubernetes?
So there are a couple of tools. You could use Prometheus. You could use Prometheus and Grafana. Then you can use the ELK stack. We have the ELK stack that's from Elasticsearch. So those two come first. I'm sure there are 1,000 more, but those are the two that I use a lot, and it gives me everything I want, basically. Prometheus and Grafana and the ELK stack, basically.
Yeah. Excellent. I guess that makes sense. There was another question. Are you going to share your slides somewhere? Because there were a few people who were interested in actually getting the links. You can drop them in the chat afterwards if you want to share them, or on Twitter or anything.
Okay, yeah. I could do that. I could probably share them on the chat and possibly share them on Twitter as well.
Cool.
I'll share them in the chat and share them on Twitter. Let me just make it public. Okay,
so you can do that afterwards. I think there's a few more questions still.
Okay.
Great, yeah. So the next question is from Peter. Does GitOps include managing persistent storage and database infrastructure?
So GitOps does whatever you want it to do for you, basically. So I would not advise putting your database stuff on GitOps, because GitOps, like I said, is just a Git repository, meaning you're putting your database details on your repository, which is as good as putting it within your code, which is not advised. So yes, I would not advise that you put your database details or put anything relating to your database on GitOps.
Yeah, it makes sense. So I think that we have one more question, didn't we? Somebody was asking, what's your name? RC was asking, just curious why you selected Argo over Flux. Because apparently Argo has a nicer UI. I feel like that might be a little bit of a, like a personal opinion, but we'd like to know yours.
Yeah. So nothing special. I think it's just a personal preference. I've worked with Argo severally and I've fallen in love with it. So it just works for me. Flux might work for you well, but for me, Argo works and it gets the job done. So yes, ArgoCD all the way.
Yeah, ultimately it's about whatever that gets the job done and whatever you feel most comfortable with, right?
Yeah.
Cool. Well, thank you so much, Praise. I think that those were the questions. Did we have anything else? I think we have one more.
There was one more just showing up. When monitoring Kubernetes clusters, do you recommend tools that provide sampling or 100% tracing?
I'm not sure I get the question 100%. I'm not sure that.
Me neither. I think this is a bit about which monitoring strategy you want to follow.
Yeah, I mean, you can try both, whatever works for you. I use ELK more than I use Prometheus and Grafana. So yeah, if you experiment with both, of course, they have their pros and their cons. So you might want to weigh the options, try this, and then whichever works for you, you implement, and then you stick with it. But for me, I work with both very well. And I'm not going to tell you which one I prefer. So yeah.
Great, thank you.
Okay, well, I think that's it for questions wise. Thank you again, Praise. It was a great talk. I hope you join us in the chat for on the Umbrella platform to answer any other questions that people might have. Up next we have a short break. Our next talk will be in about 10 minutes. But if we go ahead to, I think, was it track 4 or something where the quiz and the stretching was?
I think one is track 1 and the other one is track 4. Stretching is track 4 and quiz is track 1. Don't blame me.
If you want to do like chair stretches, go to the stretching session. If you want to do a nice fun SRE quiz and you want to win prizes, then go to the other track. I'll see you soon.